Thank you. Good. So, I'm Hugo Salgado, as I was introduced, and I'm here essentially as a trusted representative of the community selected by the Icon and Ayana people to participate during the signatures of the DNS network. So as we do that, we check that everything is done in compliance with the standards and the protocols for signatures, and ordered also to attest that everything is done transparently and responsibly. Now, this operation is done every quarter in different sites in the United States where the root key is kept. But next year we'll see a very important change, and that is why it's good to let you know so that you'll be paying attention to that. So, DNSSEC, I know that you know it. It's a structure that basically it's a hierarchical structure. When you have a domain name, the important thing is for the parents delegates there, if you have their .net, LACNIC.net, and has a parent that is, well, we go up in the scale www.lacnic.net, then lacnic.net, and then only .net. So the DNSSEC adds the concept of authentication, and integrity, so that you can validate that the responses are the correct ones. So basically it works with asymmetric cryptography, the same that we use for the DNS in the digital certificates of the websites. And each of the levels of those tabs have their own key. If I want to sign my own domain, I need to generate a key. Of course, there's a public and a private part. I keep the private part. I publish the public one in the DNS. And in addition, the important thing is that I sent my father my key. So my father certifies as he gives me my name, says what the correct key is. So that is different from the digital certificates, where in order to get validated, you need to get a certificate that is issued by a certifying authority. That, well, most of them you have to pay, but in the case of DNS, you just use the same hierarchy of the DNS. It's like a trust chain. So the important thing here is that the key, for instance, for LACNIC.net, it tells me what the correct key is. So the root tells me what the correct one is, but the root has no father. So that key is very important because it needs to be configured and hard in all the DNS resolvers all over the world, because it is there that the validation gets validated. So the key of the root key is a critical component that needs to be hard configured in all the DNS services. Now, why do we have to change this key? You could leave it there forever, but there are cryptographic reasons. And here we consider that the more it is available, somebody could could attack it with brute force, and every now and then you need to change it, like in a couple of years, so that you will destroy any attempts if those that wanted to break it. And there are also some operative things, because if you don't execute something regularly, you're more likely to forget it or for it to fail when you need it in an emergency. It's just the backups there. Sometimes it's not really a backup, because when you sometimes the data are not there, you have problems when you want to use it, etc. So it's very important to keep it updated. At the beginning, the idea was to update it every 5 years. That was the original idea, to rotate the root key, but then that was changed. There is a mechanism in the same DNS protocol that makes it possible for it to rotate automatically. So in theory, you shouldn't be worried about this. The DNS can detect when there's a new key published, to change it, to add it in their trusted keys store, and once the old one stops signing, then the new one starts validating. So my first message here is, do not panic. Everything should work perfectly. This is a second rotation. One was already completed, but it is important to be alert, because you know that DNS fails. Sometimes it's difficult to detect it. And finally, we all blame the DNS, because one of the last things that you check. So it is very important to understand that clearly. How is the root signed?
The root signed is done in a ceremony that is held every 3 months in different data centers and locations in the United States on both coasts. Of course, with security and control measures, the data centers are protected with police that are weaponed. There are iris scanning. There's a special office that is dedicated to this. There is like a cage, and inside the cage you have hard safes. So you have the cryptographic officer, we have keys, and this issue of keys have even produced TV series, people who control. But this is quite a clerical task, that of signing the root keys. Now, the important thing is that these keys are maintained in cryptographic hardware devices, the HSMs. These HSMs, to access these, you need to have at least 3 out of the 7 keys. So with this aim, 3 of the cryptographic officers have to go to that site. So this generates trust in the sense that no one will interfere, no one will be accessing this material and do strange things. Now, this issue of trust delegation implies that a bank that is a .com, for them security is very important, and somehow they rely on the security of the .com key, and this relies on the security of the root key. This is a picture of the ceremony where the new key was generated. These are the cryptographic devices that are used. These are very new. And below, you have the generated key, the printout of the final result. Now, all this information of the ceremony is public. Streaming takes place in real time, and the material and the videos are available, and the scripts and all the steps that are followed. Now, the important thing here is that on April 26th, 2024, a new key was generating. This is being published and is available in the DNS. Now, the important date is October 11, 2026, where the new key will start to do the signing. So it's important that all the resolvers already have in the key storage the new key. Otherwise, they will have issues. This is a timeline. This has been planned to take place every 3 years in the future. Right now, we are over here in the green stage in the phase of publication and standby, D. One of the important things is that in addition to automatic update of the RFC 5011, that there are also the software creators of DNS and OSs, and because of the new updates, they're going to come with the new key already installed. So the people for whom 5011 does not work, or for who haven't implemented this, the next time they install an update, or once this is updated, it will bring the new key. So what can we expect? If you don't change it, internet won't work. As straight as that. People who validate with DNSSEC, and I hope everyone, all the operators here do so, hopefully. Now, as I was saying, the first time this was signed with DNSSEC was in 2010. In 2018, the first rotation took place. It worked quite well. It was going to be done in 2017, but certain measurements indicated that we were not ready yet. So we had to wait 1 more year, and it worked quite well. There were some cases of some errors. DNS, it's sometimes not so easy to measure what is happening everywhere, but from the cases that were checked, just check the rotation of the key, was an ISP in Ireland where internet didn't work for a full day. Maybe they took time to diagnose where the error was. So it's important to pay attention. This study was done by the people of Verisign. There is a way of highlighting the root and what key a resolver has. So whenever a resolver is picked up once a day, a signal is sent to the root server stating which keys it has. This allows you to be confident that the rotation is working well. In purple at the bottom, you have the original key of 2010. In internet, it's very difficult to lose information. This key has not existed since, no longer exists since in 2017, but somehow it is configured in some places. Now the green line at the top that you cannot see very well, 100%, that's the current key, which of course is installed wherever this is validated. And in blue, right at the bottom, that is the new key. Some people did configuration by hand. Maybe some of the pioneers were a bit worried about this, but in February 2025, when this began to be published, automatically we already exceeded 90% of resolvers that have this key. So that is why we are confident that this won't cause any major problems. So this is something I already mentioned. This should be automatic. This will be incorporated into the software updates. You have to be sure that you have the latest software versions. So the root rotation should be the least of the issues. The DNS needs to be updated. There are vulnerabilities for the systems and so on. So it's always important to have the very latest versions. Check the logs and do monitoring. Pay attention to October the 11th at LACNOG, and LACNIC will be paying attention and will be informing you if any issues should arise. Now here, let me share with you some of the techniques you can apply to be sure and how you can check your systems. The keys are called trust anchors, and they are included in the configurations. When you install these, they should have the updated version. Right now, you should have the 2 keys. And what you have below is a technique that I was mentioning previously. The servers are signaled. You can then check out whether that is correct. These are a couple of recipes of the most famous open source DNS servers in Unbound, and this will depend on the type, but this is a Debian. There you have the IDs of the two keys. 2326 is the current one of 2017, and the one below is the new key. So you can verify whether the two are present. And in the query below, you see whether that signal was made to the root service. You can see this in detail in the presentation. This is how you do the bind, which is quite similar, and the NOT resolver and the power DNS recursor. This software doesn't use a signaling, but you can, doing a DNS query, see which key has been configured. You can check whether the two are there. And then I managed to finish a tool that is a beta phase that allows you to verify all these recipes are addressed at internet providers who have the DNS resolvers. But there is also a way that is quite recent that allows any common user to check whether the providers have the keys ready. This is still in the beta stage. Only the most modern softwares work this, but it doesn't very well with the caches. If you repeat the test, it might not work very well, but it's there. Tweet it gently, and if you see any error in your provider, just don't flood their help desk. But if you say that everything is fine, just congratulate them. That is the address at the top to check that out, and we welcome any feedback. It uses a technique that is part of a standard, an RFC that is quite recent, 8509, so it's not infallible so far. So that would be all, and there you have information on the root where the correct key is published. It is digitally signed. Don't believe me, just know that they're there. And as in my role as TCR, I announce whenever there is a ceremony, and I testify that everything worked well and the serious things. And I invite you to subscribe to the mailing list of LACNOG. So thank you very much. As usual, an excellent presentation from Hugo. We have time for one question. Any questions from the floor? No questions? No questions? So, because we have lunch ahead, that's the most important thing right now, after having listened to Hugo. So, let's give him a big round of applause.